Hello students, in previous lecture I have discussed about uh, the basic concepts which is related with thermodynamics as well as the PV type work done which takes place in irreversible and isothermal process, the mathematical expression for PV type work done as well as sign conventions which is used in the chemical thermodynamics as well as examples of PV type work done. Now in this lecture I am going to discuss with you about the new concept, that is free expansion. Free expansion. For that purpose, first of all, see here, if there is the n molecules of or n moles of gas enclosed in a cylinder with frictionless and weightless piston, and here the work done takes place by the system or work done takes place on the system by compression or by expansion. Then see here, if that system or if that cylinder, if it is kept in vacuum, then see here, in vacuum there is opposing force which is given by the surrounding, that is PEX. Here vacuum is there, therefore here PEX is 0, that is opposing force is 0, and here the pressure which is or the force which is given by the system which is P, and here in this condition in vacuum here P is greater than PEX, and here the difference in those is very greater, and here as PEX is 0, therefore here W work done, that is which is takes place, is W is equals to minus Px into delta V, and here see here only driving force is there, isn't it, which is takes place by the system and which is given on the surrounding, but the force, external force, that is opposing force, is absent there, therefore here piston moves upward continuously, and here as PEX is absent or PEX is 0, therefore here W is equals to 0. That means here only expansion takes place, that means piston moves upward continuously, and here the work done takes place by the system is considered as 0, as external opposing force is absent, therefore piston moves upward continuously, and that is known as free expansion. Then we will discuss about, that is work done takes place in isothermal and reversible process, that is of maximum work done. Concept of maximum work done. See here, all of you studied about that. The process is of two types, that is reversible process or irreversible process, and when the process takes place irreversible and isothermal, then work done takes place in the system is PV type work done, and here when the process takes place, that is reversible and isothermally in the system, then here maximum work done takes place in the system, which is denoted by W max. And see here, in reversible process, the process takes place in infinite steps. Work done takes place in every step, and as there are infinite steps, then the maximum work done takes place in this process. The mathematical expression which is obtained for the W max. See here, if n moles of an ideal gas which are enclosed in a cylinder, and that cylinder is fitted with frictionless and weightless piston, that piston which is movable, and here n moles of an ideal gas, and here V1 is the volume of initial volume of an ideal gas, or V1 is the initial volume of system, and here P is a driving force which is given by the system, and PEX which is a opposing force which is given on the system by the surrounding, and here P is a driving force which is given by the system, and here if here process takes place here is isothermally, therefore here T remains constant, and here difference in driving force and opposing force is infinitesimal amount, that means here P is greater than PEX, that means, and the difference between driving force and opposing force is very smaller, that means P minus PEX is equals to dP, that means very small difference, infinitesimal difference in the driving force and opposing force, and here driving force is greater than, that is external or opposing force, and therefore here we get PEX is equals to, see here, P minus dP, and here work done takes place in one step is also smaller, that is dW, and see here, as the driving force is greater than external force, therefore volume of system, that is V1, changes to V2, and here volume of the system increases from V1 to V2 by expansion, see here, by expansion, and therefore here the work done takes place in one step is also that is smaller, that is dW. Therefore, first of all, we can calculate the work done which takes place in that one step, that is dW is equals to minus Pex into dV. As here the work done takes place here is smaller, therefore the difference in the or change in the volume is also very small, and therefore we get the work done in one step, that is dW is equals to minus Px into dV. But see here, Pex is P minus dP. Therefore, putting the value of Px, that is of P minus dP, therefore this equation becomes dW is equals to here minus Px is P minus dP into dV. Therefore, here dW is equals to minus P dV plus minus plus dP dV. But see here, dP dV, that is very small, such that we can neglect that dP dV. Therefore, here dW, which is work done, takes place in this process in reversible and isothermal process, that is dW is equals to minus P dV. And here, see here, the work done which takes place in one step we get here, but this type of work done, that small work done, takes place in each and every step of that process. See here, as here the difference in the driving force and opposing force is infinitesimally, that is smaller, therefore here the piston moves upward slowly, and here work done takes place by the system by expansion, and therefore here piston moves through infinite steps. Therefore here work done takes place by system through infinite steps, and therefore we can get the total work done. Therefore we can calculate the total work done by integrating this equation. Therefore, integrating that equation, that is integration of that equation, we get integration of dW, that means here initial work done, that is takes place 0, and the final work done, that is W max, here integration of minus P dV, and here small change in volume, that is dV. Therefore here initial volume V1 and final volume, that is V2. But by ideal gas equation, because there are n moles of an ideal gas enclosed in a cylinder, therefore here PV is equals to nRT, and therefore here P is equals to nRT upon V. Putting the value of that P in this equation, therefore here we get the derivation, that is integration of dW, that is equals to integration of that, putting the value of that P, that is minus nRT upon V into dV between the limits, that is V1 to V2. The equation, that is here integration of dW, therefore here we get W max is equals to, then see here at right hand side, N is the number of moles of gas which is a constant, R is a gas constant, T is constant because here this process takes place isothermally and therefore here T is also constant, and therefore we can write that equation minus nRT integration of, that is dV upon V within limits V1 to V2. Therefore W max is equals to minus nRT, then integration of dV upon V we can write, that is integration of V within the limit V1 to V2, and therefore W max is equals to minus nRT, that is of within the limits, that is integration of V2 minus integration of V1, and therefore W max is equals to minus nRT, that is of, here we can get integration of V2 upon V1, and here the same equation we can be converted into, that is W max is equals to minus 2.303 nRT, here log of V2 upon V1 to the base 10, and here that is the equation, mathematical expression for W max. But here P1 V1 is equals to P2 V2, and therefore here V2 upon V1 is the P1 upon P2, therefore putting the value of V2 upon V1 here, therefore we get the equation, that is W max is equals to minus 2.303 nRT log of P1 upon P2 to the base 10. That is the mathematical expression for that W max. Then that equation which is obtained because of work done takes place by expansion, and here if the same maximum work done takes place by compression when the work done takes place on the system, then we can write the same expression like that, W max is equals to 2.303 nRT log of V2 upon V1 to the base 10. Here instead of negative sign we use the plus sign for compression, and that is about the derivation or mathematical expression for maximum work done. Then you should solve the numerical examples as well as the derivation in your textbook related with this maximum work done concept. Thank you.